Hi, I'm Tyler Compton, and you're watching the 5th episode of Gaming and Go. So in the last episode, we focused on the component architecture. So there isn't really a lot that we did that's immediately visible, but we can see here that most importantly, it works as it did before. You can move the player around and shoot bullets, and you can see that the player is actually there alongside the enemy and the bullets themselves. And so there isn't a lot going on that's immediately obvious, but there was a lot of work that we did behind the scenes to make this a component-oriented and very modular system. Even if we didn't necessarily need to for this simple task, it was for demonstrating this way of programming. So in this episode, we're going to focus on collision detection, and it's going to be using this architecture that we've already defined here. And you'll see how it works, and it's going to be a very clean and nice way to do collision detection. So let's go ahead and get started. Let's make a new file called collisions.go. And collisions.go is, unsurprisingly, going to hold a bunch of collision-related information. So we're going to need to define some type that describes a region with which a collision can happen. And in this example, we're going to be using a circle. And we're going to be using a circle for a few reasons. The first reason is because it does a good job of wrapping around most objects in a way that more or less covers them, approximately. And also because detecting collisions between two circles is very easy. And I don't want to get too into the math behind these kinds of detections. If I were to do polygons, it would be, it might be a whole episode unto itself explaining all the various polygon collision-based systems. So we're just going to be using a circle. And a circle, as you probably know, is defined as having a center point, which we're going to use that vector type that we used in the last episode to define the center, and a radius, which will just be a float 64. So with this in mind, we now have a fully defined circle. So if we were to create a function which detects a collision between two circles, it might look something like this. I'll return a Boolean saying whether or not the two circles collide. And so just here as our explanation for how we detect if two circles collide, we simply use the distance algorithm. And if you're not familiar with, I'm talking about like standard, I think it's called Euclidean distance, which is the square root of the difference in the x values plus, or I should say the difference in the x values squared plus the difference in the y values squared, which is something that you probably remember from school or something, or maybe you don't, and I wouldn't blame you. But remember, a circle just has 2 points and sort of a distance between those points, which defines the circle itself. So the distance algorithm is really all we need. So I think it'll become more clear once we write it out. So we can define the distance as the square root, once again, of the difference in x's between the two circles, squared plus the distance in y's, or I should say the difference in y's squared. So that's how we define our distance. Let's see, is there any issue here? Type circle has no, right. So I was doing .x, I need to do .center .x and .center .y. So you may have noticed that this whole vector type thing, as opposed to holding the x and the y directly, has cost me a lot of compile cycles as I mess it up. There might be a case to be made that it wasn't really that good of an idea, but we're going to keep it for now. So now that we have this distance between the two circle center points, we need to know how it compares to the radiuses of the circles. So if one circle is inside another circle, that means that their two radiuses intercept. So they end up being inside of each other. So if their distance is less than the combined radius of the two circles, we can say that they collide. So let's go ahead and do that. So if the distance is less than or equal to C1's radius plus C2's radius. So, that makes sense, right? The radius is defined as the furthest point out from the center that the circle is at in all directions. So the furthest collision would be the 2 points with the radius of each of their circles away from each other, touching right at the very edge. So that's how we're going to be doing collision detection here. So now we've got this, but it's not really integrated with the rest of our system yet, right? So let's go into element.go and take a look at our element struct, which, if you remember, is that type that every object that is in our game is. And, the differences between them are defined by the components in them. So the element contains only information that the vast majority of game objects or, things in the game will require. And I'm going to say that we're going to need one more of these, and that's going to be collisions. And collisions is just simply a slice of circles. And so this is to say that every element will have 0 or more collision points defined as circles, which they can collide with each other with. So with this in mind, we can go into, for instance, bullet.go and define a circle and put it in there. So let's go ahead and do that. So the circle's center is going to be the bullet's current position. So it would be bullet.position. And the circle's radius is going to be fit to the size of the bullet. But if you recall, all of the sprites, let's take a look at these sprites here. So if you take a look at this sprite, there's a lot of white space around it that we really don't want to be part of the collision. So we're not going to want to use the size of the image like we've done in the past for things like rendering. So instead, let's kind of estimate, that looks about right. We want to kind of, encompass both the tops and the sides of it. So let's say 8 is our radius. So let's use 8. So yeah, that was not a particularly scientific way of doing it, but the collision detection in games is often just a little bit fuzzy, and especially for the purposes of this game for demonstration, it's not super important for it to be accurate to the pixel. So this will be good enough for us. So now that we've done this, we can do bullet.collisions, and we're just going to append it. Okay, great. So now we've added a collision to the bullet. And we want these bullets to be able to kill enemies. So enemies are going to need a collision as well, so we can detect when the bullet hits the enemy. So we're going to do more or less the same thing here. Once again, the center point is going to be defined as the basic enemy's position, and the radius, well, let's jump into GIMP again and see if we can decide on a reasonable radius for the basic enemy. So let's see here. And again, we're going to be pretty approximate here, but let's give it a radius of, let's say 38. I think that looks about right. Okay, so perfect. So now, once we append that to the basic enemy's list of collisions, now we have a situation where the basic enemy and the bullet are set up to have collisions so that we can detect if they collide with each other. So we're in a good spot here. And now all we need to do is actually write the code that compares elements to each other and checks to see if they collide. So let's go into collisions.go. So let's define a new function called check collisions. And check collisions is going to go through every element in that registry of elements that, remember, we have as a global variable right here. That is just every element in the game, and check them against each other to see if they collide. And the reason why this function returns an error, you'll see why we do that, but it's fairly simple. So let's go ahead and use a for loop to loop through every element in elements. So we're using indexes here, and you'll see why in a second. So this for loop might look a little bit funky, but it's defined such that we get only one combination of two elements per. And I didn't explain that very well, but the basic idea is that we don't want to check collisions between element 1 and element 2 and then do it again for element 2 and element 1. The order doesn't matter in this case. We only want to check each combination once. So we're looping through every element except for the last one here, and then looping through every other element from that point to the very end here, which if that's not immediately clear as to why we're doing that, I'm not really sure how to explain it, but it sort of makes sense from a logical standpoint. You're just going to have to take my word for it for now, I guess. But I know it's a bit gross, but this would be the way that you'd want to, check every combination between two lists. So, all right, with this in mind, we now have every element, and we're going to want to loop through every collision that each of these elements define. Because remember, we have it defined such that elements can have multiple collisions. In this case, they're only going to ever have one for our purposes right now, but it would make sense that, you could imagine a more complicated shape that might need multiple collisions to define, to reasonably define its collision space. So we're just looping through the collisions of both I and j here to check for combinations between the two, or I should say collisions between the two. So let's do if they collide, C1 and C2 collide, and we want to make sure that all of these elements that we're checking against are active. We don't care about elements that aren't active. Remember, non-active elements don't get drawn, they don't get updated. Basically, nothing happens with them. It's like they don't exist. So let's just make sure that both of them are active. Okay, and then, so now what do we do, right? Okay, so we know there's a collision between two elements, but now what? Well, I'm going to tell you what. We are going to redefine the component interface a bit to have some added functionality, and that's going to be called onCollision. And onCollision is called whenever a element that a component is attached to gets a collision. So any component that does something when a collision happens, like for instance, destroys an enemy, just as a hint as to what we're going to do next, would use this method to wait until a collision happens and then do whatever needs to be done accordingly. So onCollision, and we're going to give it the argument other, which is an element, and this is just going to be passed to the method as the element that this element collided with, and it's going to allow it to return an error in case something happens. So this returns an error just like the other on methods that define the component interface, which is why checkCollisions has an error here, because we're going to be calling these onCollisions for each element. So we're going to be calling the first elements onCollision, onCollision, or wait, okay, so we're talking about elements here. So we're going to have to imbue an element with the ability to call all of its components and say, hey, there was a collision, right? Just like we do for update and for draw. So this is going to look much like update and draw. We're just going to call onCollision, pass that other value, and check the error. That's it. So now we can call collide or collision and provide the other element that this element collided with, check that error and return it if something happened, and do the same for the other element. We want to notify both elements of this collision. Okay, perfect. So now we have a function, which, by the way, I know this is super nested, but it's because it's all about checking for, all of the combinations of every collision within every element. So it's kind of unavoidable, but this is just how it's going to look. checkCollisions checks every element to see if there's collision. So we'd want to call this every frame, and collides is this function which checks for collisions between circles, which we're using in checkCollisions. Now we've added a hook that components can use to find out if there is a collision with the element that component is attached to and take some kind of action. And we've given element the ability to, or given element a method which just is called when a collision happens and notifies all of its components about the collision. And now elements hold a collisions slice, which holds all of the circles, which we use as collision points, which define how an element can be collided with. So, okay, great. So let's go ahead and make use of this here. So obviously now all of our components are broken because now they need to implement this on collision method, and we haven't put that in any of them yet. So let's go ahead and do that. So let's start with bullet mover just because it's here. And let's not put any functionality in any of these right now. We're just trying to fix the build here. And we're going to do it for both keyboard shooter and keyboard mover. And I have a feeling that keyboard shooter and keyboard mover are not going to be using these, but of course we need them because we need to implement that component interface. Okay, let's see. So where are we at now? Sprite renderer, of course, needs it too. And again, I don't see sprite renderer making use of this, but we're going to have to add it anyway. Okay, so now we fixed the build, but because we're never calling this check collisions function, nothing's ever going to happen anyway. So let's go ahead and fix that. So now on every frame, let's go ahead and call check collisions and just check that error. And print it like we normally do, just so we know that it happened. And there you go. So, well, we don't want to return. We want to just, well, we do want to return. We just don't return nil. Okay, so now we are checking collisions every frame, but we're not doing anything when these collisions happen. So let's go ahead and add to that. So what would be the best thing to do here? So we want to detect a collision between a bullet and an enemy. So when a bullet detects a collision, and I'm just going to add this functionality in bullet mover, we want the bullet to disappear. We don't want the bullet to shred through enemies. It's not like a special piercing bullet. It's just one that gets destroyed when it touches enemies. So we're going to do mover and then reference the container, which is the element that bullet mover is attached to, and set that active value to false. So, all right, let's see. And of course, we still need to return nil to say that there wasn't an error. So let's go ahead and build this. Okay, so the fact that bullets aren't appearing makes me think I might have messed something up. So let me just double check our work here. Well, let's just make sure that this is the problem. Right? Let's go into bullet mover and just print something when this happens. Okay, so there does seem to be a bit of a problem here. Oh, and I know why this is, because I forgot something. So when we define a collision in bullet, we are giving it some static position here, right? But the bullet moves. So we need to make sure that in the bullet mover, which is of course in charge of moving the bullet, we update this value. So if we do mover dot collisions, or mover dot, you got to reference the container, dot collisions, and we know that there's just one, so we'll just do it like this, dot center, we'll set that equal to the component's position. And I guess since we are already getting the container up here, we'll just use that convenience value here. And let's see if that helps. Okay, now we're talking. So as you can see, bullets get destroyed when they touch enemies, but we don't want just the bullets to get destroyed. We want the enemies to get destroyed too. So with that in mind, I'm just going to go ahead and get rid of this test thing here. And so I would call, so in this we kind of cheated a little bit. And to be fair, this might not be good component-oriented design. The fact that bullets disappear when they hit enemies, you might say is not a moving-related task, so perhaps it should have been taken out into a separate component, but we kind of cheated things a little bit. For basic enemy, though, we're going to create a new component for this, and we're going to be calling it vulnerable to bullets. So this component, when attached to something, will give it the functionality of being vulnerable to bullets, meaning that it gets hurt when getting hit by bullets. Okay, and since this is a component after all, it's going to contain a reference to its container, which again is the element that the component is attached to, and we're just going to create a function new vulnerable to bullets, which is just going to take a container. And you know, it's a pretty simple function. Maybe it shouldn't be a function, but just for the sake of consistency, we're going to make a function here. Okay, perfect. And now, of course, we need to implement the onDraw functionality here. Which we're not going to be drawing this. This isn't really a drawable entity, but we do need to define it. And then on update as well, well, there really aren't any updating tasks here, at least yet. So we're going to be doing nothing. But on collision is what we're interested in, because we want the element that this is attached to be sensitive to bullets. And when it gets collided with one, we want to just go ahead and set that container element's active value to false. So they're just going to immediately die. Okay, so now we just attach this to our basic enemy. And then we should see that the enemy is now vulnerable to bullets. Okay, let's see. Oh, right. Wait. What did I do here? Oh, I gave onUpdate the renderer. OnUpdate doesn't use renderers, so we don't have it as an argument. Okay, now we should be good. So let's take a look. And yes, okay, now we can destroy enemies. So just as a little extra, let's go ahead and make it such that... So one thing you might notice is that actually, while vulnerable to bullets advertises itself as making the element vulnerable to bullets and that's it, it actually is vulnerable to anything, because we don't actually check to see what we're colliding with is a bullet. So how might we do that? Well, remember that a component's its uniqueness is defined by the components, or I should say an element's uniqueness is defined by the components that it's attached to. So we can't check the type of the element, because the type will, of course, just be element. So in this situation, it might seem like the component-based architecture kind of breaks down a little bit, but I wouldn't say so. There's just a different way of approaching this problem. So there are kind of two ways. You might want to attach a component to the element to say, hey, this is something that hurts something. But then you're kind of just attaching a component to describe the object, and it doesn't actually add functionality. So that doesn't seem like a very good option for us right now. Another option is to add a tag value to elements. And the tag has some descriptive, something about it that says, hey, this is something of approximately this type. And so oftentimes you'll have multiple different kinds of elements share the same tag. So we might have, for instance, an enemy tag, and the player might check to see if what it's colliding with is an enemy, and if so, take damage. But for right now, we're just going to use it right here in bullet and set that tag to bullet. And then in vulnerable to bullets, we check to see if this other element's tag is equal to bullet, and if it is, only then do we destroy the enemy. Okay, so obviously there isn't any actual change of behavior because it seemed to work before, but that would be how we do it. In situations where this game gets more complicated, and you could imagine there are situations where other things collide with the enemy too that maybe shouldn't destroy it. But hey, now we've got the startings of a game here, right? So the obvious next step here would be to add some kind of challenge. Maybe the enemy shouldn't die in the first hit. Maybe they should come down and actually try to threaten the player. But we'll leave that till the next episode. Until then, I'm Tyler Compton, and thanks for watching.